All right, let's look at the vertex of quadratic functions. And we're going to look at two types of quadratic functions. Let's look at a graph first before we get into how to find them. So here's your x-axis and y. And let's say we have a graph that looks like this. This is some function f. Now, we can identify a couple points on this graph already. We know that if it crosses the x-axis, that's an x-intercept. So we have a point there and a point there. So those are our two x-intercepts. We also have a y-intercept where it crosses the y-axis right there. We know how to find those. You want to find an x-intercept, you let y be 0. You want to find the y-intercept, you let x be 0. All right, now there's one extra point here that we want to find, and that is the vertex. The vertex is basically the peak or the valley, so we can say it's the max / min if you want. And so on this graph we have a point up here that would be our vertex. And that's the point we're going to find right now. So the first type that we want to look at, first type of quadratic function is of this form. So these are going to be some steps here. Graphing a quadratic function of the form, and this is a form that we're all used to seeing already, and so that's why I'm starting with it. Of the form, let's call it f of x is equal to ax squared plus bx plus c. So what we want to do is we want to graph this function that's of this form, and here are the steps to do that. The first one is going to be something new, but it's relatively easy. If a is greater than 0, now what represents a in our function here? It's the number attached to the x squared. It's the coefficient of the x squared term. So if that number is greater than 0, just a shorthand, we're going to say it opens up. So let's think about this for a second. When I mean it, I mean the function we're working with. It opens up. That means it opens up like this, like a cup, like a U. So if it opens up, that means we're going to have what type of value down here at the bottom? A minimum value. So if a is greater than 0, it opens up. Go ahead and think of it as up and form the U in your head or with your hand. So that gives you a min down here on the bottom. So this gives us a min. All right. This is still part of number 1. If a is less than 0, what happens? It opens down. So now think of it as an upside down U or cup, and it forms a point up here on the top, which is a max. So that forms a max. So just think of it in terms of your a value. My a is greater than 0, so it opens up. And then that gives me a minimum value. If my a is less than 0, it opens down, and it gives me a maximum value. Okay, step number 2 is now we need to find the actual vertex. So step number 2, this is another new one. It's a point, and just watch me before you write it. We're going to have an x value and a y value. So I'm going to go ahead and here's going to be my x and here's going to be my y. So to find the x value, we need to compute this. Negative of b divided by 2 times a. So all you do is just plug numbers in here and then simplify. So you plug in whatever b is, which b is the coefficient of your x term, and then it's 2 times a, which a is the coefficient of our x squared term. So we have our x value now from our function. So now we need to take that x value and plug it back into the function. So our function we're using is called f. So then I just take whatever value is here and I plug it into my function f. So I'm just going to rewrite negative b over 2a. And this will make a little more sense when we do an example. The third step is find x and y intercepts. And then number 4 is plot. So you plot everything and connect the dots. All right. Let's look at an example. Example 1, excuse me. Graph. Let's call this one, let's call it f of x equals x squared minus 2x minus 35. And we're just going to follow the same steps that you just wrote down previously. So use that as a guide to help you if you need to for right now. So number 1. Number 1, we look at a. What is our a value here? It's the number attached to our x squared. It's the coefficient here. If there's nothing written, that means it's a 1. So we say a is equal to 1, and is 1 greater than, and 1 is greater than 0. So that means it opens up, and we're going to have a minimum value. So that's good information to keep in your head when you're graphing these things. You get little tiny bits of information, and as long as and then at the end we'll just combine them and it'll make it easier to graph. So we can say opens up, and that gives us a minimum value. And so now number 2, which is the vertex. So the vertex is equal to negative b over 2a, comma, f of negative b over 2a. So start by just finding the x value first, is negative b over 2a. So do some side work. So we're going to start over here with negative b over 2a. And we're just going to plug in these values. Remember where we find these values, b and a. So a up here is 1, b is negative 2, and c is negative 35. We're not going to be using c in this case, but it's still good info to write down. All right, so let's plug in. Start by doing it like this. You know the negative and the divide sign is part of the equation. So negative and divide. Let's go ahead and just write those in and get it over with. This way we don't forget this negative here, because that's easy to do. And b, we said was negative 2. So we'll plug in negative 2 there. And then it's 2 times a, which is 1. Now it's just simplifying. Negative times a negative gives me the positive. So that's 2 on top. And then on the bottom, I get 2, which is equal to 1. All right, so that's our side work just to figure this x portion out. All right, so kind of ran out of room here, but follow along. So this is equal to, this is equal to negative b over 2a, we just said was 1, comma, and now we have f of negative b over 2a. So negative b over 2a we just found to be 1, so that's what we're plugging in here. So we're we started with our vertex formula, we found our x and plugged it in here, and it's the same value over here. So now we just have to evaluate the f function where x is 1. So now we're going to do that side work over there. So f of 1, that means you're plugging in 1 into the f function everywhere there's an x. So now you're going to get 1 squared minus 2 times 1 minus 35. So you get 1 squared minus 2 times 1 minus 35. Simplifying this gives you 1 minus 2 minus 35, which is equal to negative 36. So I'm going to come back, let me erase this portion here. I'm going to come back over here, and now I know what f of 1 is. It's negative 36. So this is equal to 1 comma negative 36. And that is my vertex. That would give me my minimum value in this case. All right. Step 3, we need to find the x and y intercepts. Hopefully we've gotten the hang of that, but we'll go over this just in case. So the x-intercept, we always let the other variable be 0. Let y equal 0. Then I'm going to write my function x squared minus 2x minus 35, and I'm letting it equal 0. Now, what do you have to do to solve this for x? We have to do the AC method, or you have to factor it by whatever means you like to factor. So I'm going to skip the AC portion here, and I'm just going to give you the answers, and if you're struggling with this, then please get help. So when you factor this, you get x is equal to 7, and x is equal to negative 5. Remember, our x-intercepts are points, so we need to write them as points. This is 7 comma 0 and negative 5 comma 0. I'm running out of room fast. So those are my x-intercepts. I'm going to just rewrite my vertex here so we have it. You don't have to rewrite it on your paper. 1 comma negative 36. And then we need to find the y-intercept. So the y-int, we let x equal 0. And then let's write our function. I kind of messed up there. I'm just going to rewrite it. F of x equals x squared minus 2x minus 35. And now we're just plugging in 0 for x. So we get f of 0, which is the same thing as y. 0 squared minus 2 times 0 minus 35. Simplifying this, you get negative 35. So that tells me my y-intercept is negative 35. We don't leave it, we write it as a point because it's an intercept. So 0 comma negative 35. All right? And now step 4 is to graph this thing. So we have some big numbers in here, and it doesn't have to be exact. It doesn't have to be exact proportions here, but I'll do my best. X-axis and y-axis. So let's start with what we know. We know that A was greater than 0, so we're going to have a cup or a U. We're going to have a minimum value at this vertex. We're going to cross the x-axis at these 2 points, and we're crossing the y-axis at this point. So let's plot our points first, and then we'll go from there. So 7, 1, 2, 3, 4, 5, 6, 7, and negative 5, 1, 2, 3, 4, 5. So we have a point here. I'm going to erase a little bit. point here at 7, 0, negative 5, 0. And then our y-intercept is 0, negative 35. So we'll just say negative 35 is right here. And it doesn't have to be proportionally. As long as you write that it's negative 35 here, that's perfectly okay. And then we need to label our vertex, which is the lowest point, the minimum. So we're at 1, negative 36, which is just one below. So just label it that it's negative 36 and put it right here. And those are our points. Now it's just connecting it to make it look like that upside down U. And this is our f of x function.